In this lesson, we'll cover basic user interaction in Python. Our hands-on work will consist in creating a couple of programs that ask the user for an input through the keyboard. We'll see how to convert this input into different data types for further processing, and I'll conclude with some remarks about Python runtime errors, also known as exceptions. Let's get to it. The programs we've been writing so far don't provide much of an interactive experience for the user. These programs have simply consisted of a set of predefined operations executing sequentially and whose results are then written into the console. Well, it's time to change that. We'll now introduce the tools needed to allow the user to provide input data to the program and to make your program's behavior dependent on that input. There's a built-in function in Python that serves exactly this purpose, and that is the input function. In its most basic form, this function doesn't take any arguments. The Python syntax for function calls that don't expect arguments still enforces the use of parentheses after the function name, with no additional content between them. When Python executes the input function, the program stops and waits for the user to enter a line of text from the keyboard. The user can enter characters, digits, and symbols, and may also use the backspace key to correct typos if needed. When the user presses Enter, the program resumes its execution, and function input returns the text entered by the user in the form of a string, which can then be processed by the subsequent lines of code. What do we mean when we say that a function returns a value? Well, it means that the execution of that function produces a result, which can then be used as part of a Python expression or on the right-hand side of an assignment. For example, take a look at the following lines of code. When Python runs the first statement, the program waits for the user to enter a string. If the user now enters, say, text hello, and then presses enter, this string is returned by the input function and saved into variable x. The program then continues executing the print statement, which will print hello into the terminal. As you can see, this is an example of a very simple interactive program, in which the output seen in the console is dependent on the input provided by the user. Now let me propose the following problem, which I'd like you to complete before continuing to watch this lesson. Use the code editor to create a new project titled Input. Your program should first print a message asking the user to enter their first name. The user's first name is read and saved into a variable. The program should then print a second message asking the user for their last name, and this input should be saved in a second variable. Finally, the program should print a greeting message that reads, hello, comma, space, first name, space, last name. This is an example of such program executing. The program asks for the first name, to which we reply, John. And then it asks for the last name, to which we reply, Smith. Very original, I know. And it ends with the expected greeting message. So please pause the video and get your hands dirty. I'll see you in a second. How did that go? Let me show you the steps I followed to solve this problem. But keep in mind that there might be other equally valid variations of my proposed solution. I'll start by clicking on New Project, naming my project Input, and pressing Enter. Now remember our number one rule when writing code. We want it to be properly documented with Python comments and structured as fragments composed of a comment, a block of code, and an empty line. So let's start with the first block, which will consist in asking the user for the first name and reading it from the keyboard. We write a comment that says, read first name. This is followed by a print call, print, enter first name, and the creation of a variable called first name that will capture the result of function input in an assignment. There's something I'd like to point out here regarding variable names. As we studied before, we have quite some flexibility when naming our variables. In spite of the seeming convenience of using short names, such as X, I strongly recommend using self-explanatory and easily identifiable variable names, even at the expense of some additional code verbosity. Now and in the future, we'll avoid any type of abbreviation when naming our variables and other symbols, with the purpose of making our code as readable and maintainable as possible. Also, we'll stick to a variable naming convention based on lowercase characters, with additional underscores to separate multiple words within a variable name. Hence, first underscore name. We'll save other naming patterns that include uppercase characters for other types of identifiers, as we'll reveal later on. Moving on, let's leave an empty line and write the comment for the next block of code. Read last name. The next two lines of code mirror the previous code block. Print, enter last name, and last name equal input, followed by another empty line. The strategy I'll propose here for printing the greeting message is based on concatenating all of its components with the plus operator, and then using a print call to print the result. Let's start with a comment that reads, show greeting. We'll now create a new variable called greeting, to which we'll assign the concatenation of string hello, space, plus the string contained in variable first name, plus a space, plus the string contained in variable last name. Finally, we use one last print call as follows, print greeting. And this completes our program. You may now run it if you haven't done so earlier and verify that it works as expected. As I mentioned before, this code is just one of many alternative implementations that would achieve the same behavior. For example, instead of saving the greeting message in a variable and then printing it, you could have used a single print call to which it passed all components of the greeting separated by commas, like so. With this option, you would have to omit the additional spaces in your strings, as they are implicitly included as separators for the multiple arguments passed to print. I'm going to show you another useful trick that we'll take advantage of in the future. A more sophisticated use of the input function allows us to pass a string as an argument. If this argument is present, the function prints that string into the console before it waits for the user to enter new text. This gives us the opportunity to merge the pairs of print plus input calls into just one input call that accomplishes the same behavior. In our code, this would imply removing the print call, like so, and passing the desired message as the argument of function input. A slight difference in the behavior of this code lies in the fact that the cursor won't move to the next line after the prompt message is printed. For this reason, we include an extra space as part of the prompt string, which makes the cursor stop one position away from the colon character. To wrap up this task, please apply this improvement yourself for the second pair of print and input calls, and verify that the program runs correctly. Pause the video now, and I'll see you when you're done. If you enjoyed this content, you may watch the rest of this lesson at computersciencecamp.com, linked in the description below. You'll be able to follow along with coding samples and problems in our embedded code editor. Drop your questions in the comment section below, and don't forget to like and subscribe to help support the channel. Thank you, and happy coding!